Here's the setup for the next lab. You're going to take a meter stick. You're going to attach a binder clip in the middle and flip it up and put it on the clamp that's mounted on a drawer. You should be able to get it to balance pretty much right in the middle. Now you should have two binder clips that are of equal mass. You can check them out on your scale. Now you take the binder clip and you can attach it over here and watch what happens. Hey, it's no longer balanced. So where would you have to put another binder clip to get it to balance? Yeah, on the other side. Move it in too close. Hey, it doesn't work. Now we get serious with some larger objects. You want one object about twice as heavy as another. And you can check it all out on your scale. And you can add beans, take beans out, put change in there if you want to. You can use a water bottle and adjust the amount of water so that you end up with two objects, one twice as heavy as the other. So this bag is about 130 grams, including the clips. And over here I have my water bottle. Well, that's about 65 grams. They don't balance in the middle. I had to move the heavy one in a little bit, didn't I? Your goal was to figure out the math for this. What kind of formula can you make to make this work? Let's just call this the seesaw lab. You've got your binder clip attached to the meter stick in the middle, hanging from the clamp. Now you've got your objects hanging here. Well, this is a diagram of the apparatus. Now, since our electronic scale works in grams, you could do the lab in grams, or you want to convert to a force. A rough approximation would make that 1.3 newtons and that 0.65 newtons, and you can check that out on your spring scales. They're calibrated in both newtons and in grams. The question now is, what about these distances? We have to label them. Now we have D1, D2, F1, and F2. Could you come up with a formula that would show us how this balances? If I gave you a force and a distance and another force, would you know where to put it to make it balance? So this is part one of the lab. You need to come up with a formula for two forces to make it balance. Once you get that working, in the next part, you can try three objects. Now, if you run out of binder clips, you can hang your weight just from the paper clip hanging it over there. They tend to move around a little bit, so be careful. So for part two, you have to use three objects and get it all to balance and label those distances and try to come up with the math to make this work. So in other words, if I gave you this guy and that guy's weight, and I told you where they were, and you knew that weight, would you know where to put it to make it all balance? That's the kind of math you have to come up with. Yeah, there's a part three. Could you get this thing to balance with just one weight? Yeah, that's part three, one weight. You might have to get a little creative. Remember, during the lab, you need to have a diagram for each part. Label the distances. Label the forces. Use variables, F and D. Show your data. And of course, the big one is show your formula. Just don't write some numbers down. It's got to be forces and distances making up a formula. Have fun, everybody.